In this week of our OpenHPI course about internet networking, we want to discuss about computer network technologies. We will speak about local area networks and we will speak about wide area networks and the technology behind. Now let's start with an introduction to the local area network technology. Local area networks typically are called LANs. This local area network, they connect computers which are relatively close to each other. Relatively close means maximally several hundred meters. In contrast to a point-to-point connection of two computers, computers that are linked to a local area network, they share a common network infrastructure and transmission medium. In an end-to-end connection, here we have the computers, and the computers connect to each other, and then they can do what they want. If we have several computers in place, and they use a common network, then they may be interconnected in such a way, and to communicate, for example, for communication of A with B, one can use this way, or one can use that way. So in this way, the computers, and for example, if C wants to connect to B, then also C goes this way, and then here you see there are different computers using common infrastructure, common wires, or common lanes for their interaction. So in this way, when the network infrastructure is shared, the network resources, of course, are used in a highly economic way. So we can connect many computers to each other, and we do not need so much network infrastructure. In such a one-to-one situation, each pair of computers needs their own connection. And you know, if we have n computers, we need n square such connections. So these local area networks, these are the most widely used form of computer networks. They are typically private networks, so in a company or at home, one installs such a local area network technology, and one is fully responsible for the use of this network. One can make decisions what kind of technology is used, and one can see what is the limits of this network technology, how these different network technologies fit to a situation, and then one can select the best fitting one. There is a problem. The problem is if there is a transmission medium used by different computers, if this is used for different communication lines, then there is a high demand for coordination and administration. How this is solved in this local area networks? The basic idea here is that information is divided into data packets, and the different data packets are sent one by one through the network. We already discussed this principle of packet switching. The characteristic of the most local area networks is that these networks are broadcast networks. Broadcast means we have a computer, and the computer sends out, and computer wants to send something, and the computer sends his data packet to all the other computers which are connected to this network. Of course, the packet is only, typically it's only should receive one of these many computers. So what we need is a way to identify the addressee, to identify the receiver of a data packet. And this is done by an address. And the data packet has an address field where exactly can be specified what is the intended recipient of the packet. Now the packet we said in the broadcast network is sent to all the computers that are connected to the communication infrastructure. So each computer is receiving, each of the connected computers is receiving the data packet, but it is assigned only to one of the computers. So what are the other computers do? They look and check the address, the receiver address of the packet. And if this receiver address does not fit to the own address, then packet is discarded. And if the address fits, then the packet is processed, and that means it is handed over to the operating system and to the corresponding application. So a common characteristic of such local area networks is that these networks are broadcast networks. Packets are sent to all the other computers that are connected to the network, and then every one of these other computers checks by means of an address check whether this packet is assigned, whether it is the receiver of the packet or not. Question why this broadcast technology is used. This is simply for getting speed. So there is typically no logic to decide what is the other computer, what is the best path to it. No, the packet is sent over all the paths that are available. That this worked, each computer in a LAN need to be uniquely addressed. So each computer needs an address. What is such an address? Address is nothing else than a value in a very specific format. What is important is that this address is unique among all the other computers which are connected to this network. If we are precise, then the address is not the address of the computer. The address is the address of the network interface of a computer. That's important because if we discuss later routers or other computers which are connected to different networks, then of course they need different network address. So the address, shortly speaking, of a computer, more correctly speaking of a network interface, exactly identifies a computer among all the other computers in the network. Now with the address, we can observe the following. We already discussed that on the different communication layers of the protocol stack, different tasks are fulfilled. And to make things easy, it is allowed for the designer on each level to define their own address format. The reason for this is that on the different levels, different tasks have to be fulfilled, and for the fulfilling the different tasks, different information, administrational information are needed. So in this communication protocol stack, the protocols on each layer can use an own address format. Though there is not the address, on each level there is an address. What is important in all the cases is that the address is uniquely identifying a computer. Now we want to transmit data. We already discussed that we do this in form of data packets. So each packet needs the information. What is the addressee? What's the receiver of this packet? And this information is put into a header. Into a header, if this is a data packet, then a header is put in front of the data packet, and all the information which is assigned, administrative information, which is assigned to the data packet on a certain layer, are typically located in this header. So first, the address of the receiver. What is also needed for different things, that the sender of the data packet is identified, and this is done by the address of the sender. So in a header we have the address of the receiver as well as the address of the sender, and then there are other additional administrative information that are necessary for the correct transport of the data packet. Now let's have a closer look how such local area networks are designed. And let's start with having a look to the LAN communication interface. The communication interface is that component that filters out the incoming packets, checking the receiver address and making decision, is it the own address or it's not the own address? In case it's the own address, then this packet is handed over to the operating system and is processed. And if it's not the own address, the packet is ignored. So each data which wants to be sent through a local area network needs to pass the LAN communication interface. That means it is packed into a packet, and that header is put in front, and in this header there is the address, the receiver address and the sender address put, and all this is done without the computer's central processing unit. This is of course done for efficiency and for speed, so that the communication, the work that is needed to organize communication is independent from the, and is not using resources, computing resources of the computer. This is performed by this LAN communication interface. A short look to the addresses. There are different types of address. What we discussed up to now, this is an individual address. An address for an individual computer that exactly specifies this individual computer. Besides of these individual addresses, we have so-called multicast addresses. And by means of multicast addresses, it is possible to address with one address a group of different computers connected to the local area network. And then the third type of address, it's so-called broadcast address. And this is an address that makes it possible to send one packet to all the other computers connected to the LAN. This is, for example, important for some administrational work, for some updating and other things. Very important when we speak about local area networks and the local data management in a local area network are so-called MAC addresses. MAC is Media Access Control addresses, and these are the hardware address of the LAN communication interface, of this connection between a computer and the network. So it's a MAC address. The MAC address only appears within one local area network, and it must be unique. It must be unique so that if if a MAC address is used, the computer, which is the receiver of a data package or sender, is uniquely identifiable. If we have a closer look to such MAC addresses, there are different possibilities how to get such addresses. The first way is, and these are the so-called static addresses. This is a worldwide unique hardware address that is assigned by the manufacturers of a local area interface card. We know address need only be unique on the local area network within the local area network. But if such a static address is worldwide unique, then there is no problem using it in a single network. Besides of the static addresses, we have so-called configurable addresses. These configurable addresses, they are determined freely by the network operator. The network operator needs to guarantee that each MAC address is only used once in a network. So when he assigns such configurable addresses to the single interface cards, he needs to take care that's uniquely assigned. And then, as a third group, interesting group, is the dynamic address, are the dynamic MAC addresses. And here the LAN interface card initiated automatically when it starts to work in a local net, when it starts to be connected with a local area network, it automatically starts the assignment of a hardware address. Since this hardware address needs to be unique, it is possible that in this automatic strategy for assigning such an address, there may be failures, so that perhaps a second or a third try is necessary for a host to get such a valid dynamic address. The format of the MAC addresses is specified in the IEEE 802 addressing scheme, and the format says that such MAC addresses may have two different sizes. There is a 16-bit size MAC address type, and there is a 48 MAC address type. We have discussed the addresses, the format of the addresses in a local area network, MAC addresses, and now we have to see how the packet format is defined. We already have seen that each data packet consists of a header and a payload. The payload is the user data, but the payload may contain also other administrational data from other layers of the communication protocol stack. What is assigned in the header, we already mentioned, is the sender address, and it's the receiver address, and then some additional administrational information, for example, the type of user data and others. Now, that's important, each layer of the data packet is allowed to add its own header. So if this data packet is sent over is handled by the next protocol layer, next protocol layer can take this as the load of the payload, and here have a new data packet. And this can be done layer by layer, so that you see there is a lot of administrational data in such data packet. And for the designer of such network communication protocols, it's important to have a good balance in one sense, to help by means of such administrational data that the data packet, that the communication is supported in the best way. On the other side, not to overload the infrastructure by too much of this administrational data. When we speak about local area networks, we have to see what is special hardware that's needed. We already discussed the LAN interface card. LAN interface card has many names, for example, network adapter, LAN communication interface card, network interface card, NIC and others. This is a hardware that's needed to connect a computer to a LAN. It starts, for example, in a wired LAN that a switch fits in, and the LAN interface card takes care that the information that the user of a computer wants to send over the local area network is performed in a sequence of signals that may be sent via the network. These LAN interface cards differ from LAN technology to LAN technology. So they are specially designed for a certain purpose, for a certain technology. Later we will see some examples of different local area network technologies. So this interface card is specific designed for one of these LAN technologies. A LAN interface card works and functions like an input-output device, taking over all the details of packet transmission, and so the transforming to the signals, the back transform of the signals into bytes. And this is done without accessing the CPU of the computer. The LAN interface card is able to correctly interpret the physical signals which are transferred in the LAN. So we have wired LANs. Typically the signals are electric signals or optical signals. We have other local area networks, the wireless area networks, where the signals are radio signals. So this is a task of the LAN interface to transform the physical signals into bits and bytes, and vice versa. We already discussed in such a LAN, local area network, which is based on a broadcasting of the data packets. The LAN interface card is responsible for filtering out the non-relevant data packets. There's more LAN hardware to mention. We have, beside of the network card, we have so-called network analyzer, also called network sniffer or packet sniffer. Perhaps you have heard it also in the context of attacking networks. Such network analyzers, these are portable, typical portable devices, or also available in form of software, special software, that's used to determine the performance of a local area networks as well as for error directing. So with such a network analyzer, the operator can monitor the work of a LAN and can see whether there is a failure which influences performance, whether there is an overload situation or others. The way how this is organized, the way how the network analyzers are working is that it listens to all the data that is sent over the network. This is done in the so-called promiscuous mode. And in the promiscuous mode, every received packet can be forwarded to the analysis software of the network analyzer for further examination. Not only those packets with the address, where the address agrees with the address of the corresponding computer, all the packets in the promiscuous code can be received and can be analyzed. And this is exactly the reason when I mentioned that this is sometimes misused for spying out networks. Then such sniffer, the packet sniffer, can be used also for that purpose. But originally they were designed to give an operator, the network operator, a tool in the hand to monitor the correct work of the network he's responsible for. The network analyzer can also be implemented to monitor very specific computers if they are for some reason important to see and to guarantee that a certain computer in the network, connected to the network, works correctly and has good communication situations, and one can use the network analyzer also to specifically monitor a certain computer. Typically they are designed to monitor a network. Now let's have a look to important LAN, local area network technologies. The most famous local area network technology is the Ethernet. Beside of the Ethernet, there is the token ring technology. Over many years it was a main rival of the Ethernet, but the Ethernet made it. Beside of token ring technology, we have FDDI, fiber distributed data interfaces. It's very similar to token ring technology, but instead of electrical wire, it works with optical fiber and some different access mechanisms. Then to mention another important local area network technology is ATM, the asynchronous transfer mode, which is the basic technology also for by ISDN. When we start, I mentioned the LAN only works in a relatively restricted, over relatively restricted distances. The reason is that this broadcast mechanisms, the signals become over a long distance weaker and weaker. So when we discuss how we can enlarge a LAN, we have to see which kind of possibilities exist to expand a local area network. And yes, there are different special hardware components that allow to expand a LAN, a local area, at least by a certain distance. To this hardware, for example, belonging the LAN repeaters. With the repeaters, it is possible to extend a communication line, and the technique behind is that the signals, the electrical or optical signals that become weaker and weaker and weaker over a long distance, that they are amplified, that they are refreshed. We can use other hardware components to expand a local area network. For example, we can use hubs. Hubs are tools which make it possible to connect a computer to a LAN segment. By means of such hubs, one can also aggregate different LAN segments into one segment. So all the packets that are transmitted to every connected device. Bridges are more smart tools, more smart hardware components to extend a local area network. Here, by means of bridges, it is possible to interconnect different LAN segments, which are treated after interconnection as separate segments. We will later see, when we speak about collision of signals, that such a LAN segment is a segment where we have this broadcast transmission mode. When we have different segments, then we can have different broadcasting in different segments. And by means of bridges, one can interconnect such different segments. And the bridges only transmits a packet into the other segment if the receiver of this packet is really a part of the other segment. If the receiver of the package is inside one segment, then the bridge does not forward this package to the another segment. And then we have switches. Later on we will see that all this LAN hardware, LAN expansion hardware is working on different levels of the protocol stack. Then we have such switches, and by means of such switches we can connect computer to a LAN segments, we can interconnect different LAN segments, and also here it is a device that not forwards the packet to another segment if the packet receiver does not belong to the other segment.